Hi everyone, my name is Kishore Balaji. This project is demonstrate how I fine-tune the GPT-2 medium language module for a medical question answering task using LoRa and QLoRa techniques. The goal was to adapt a general purpose model to generate accurate concessions and medical answers effectively using Google Colab. Um, on a project overview, the main objective was to train a model that can answer domain specific questions in medicine. Instead of retaining a full model, I used parameter efficient fine tuning, a perfect which updates only a small subject or parameters. This makes fine tuning feasible on limited hardware while still improving accuracy. Um, so I used Google Colab Notes to uh, run the task. So I used datasets from Hugging Face. These are the environment setup. Um, these are the GPU check and environment setup. On the next part, I'll go to the data preparation. I used the Med Alpha Medical Meadow flashcard datasets from Hugging Face. It contains consistent questions and answers pairs for medical concepts. After cleaning and removing duplicates, I formatted data in an instruction style structure, a question followed by an expected answer. I split into 70 15 15 for training, validation, and testing. Mm, Next part, I'll go to the model architecture, LoRa and QLoRa. The base model was GPT-2 medium, around 355 million parameters. Using LoRa, I inserted lightweight adapters layers that learn task-specific weights combined in QLoRa quantization. This allows training with 4-bit precision while maintaining F16 accuracy, perfect for a single T4 GPU collab. Uh, so these are the model selection. I used GPT to medium and QLoRa method to run it. On the next part, I'll go to tokenization and Clarita. On the next part, I've done the training setup. I ran training for 3 years with a 2E4 learning rate. Each batch contained 2 samples, accumulated 8 times to simulate a large batch. I enabled gradient checkpointing for memory, saving and evaluating the model every 100 steps to track progress. These are the training metrics what I got it from as an output. These are the training setups. These are the training loss validation and then eval loss. This is an hyperparameter optimization to optimize the model. And steps training loss validation loss and step training loss validation loss. These are the eval loss numbers. On next part I'll go with an evaluation. These are the evaluation result. Compared to the baseline GPT-2, the fine-tuned model achieved major gains. ROJ1 improved from 0.31 to 0.43 and ROJ-L rose by over 40%. This demonstrates strong adaptation to medical text patterns. On error analysis, analyzing model outputs revealed 3 common errors. Some answers were too short, others overly verbose, and some lacked specific medical terminology. These insights help identify next steps. Large datasets retrieval augment generation, and RLHF alignment. These are the evaluation part, what ROJ 1 and ROJ 2 and ROJ L. These are the error analysis what I've done, and what is the error analysis what I've done till now. For example, what is the name of the fatal integral bacterial that is capable for living in the neutral epithelial cells? I refer the bacterial medium that's capable of living in the neutral epithelial cell in Nigeria. I given the error as too short. These are interferent pipeline what I used. I asked what are the early symptoms for pneumonia. Preventing pneumonia is simple, but reducing a risk of getting pneumonia. And FSTMO is an example query that questions what are the symptoms of pneumonia. The fine-tuned model response cough, fever, chills, and example like that. Impact on learning. The project proved that the parameter efficient fine tuning can deliver high quality domain specific results on low cost GPUs. This shows how smaller institutions or startups can adopt LLMs without need huge compute budgets. Um, these are the reference and links for our GitHub project and the collab. I use tools Hugging Face, Preferred, and Buds and Bytes. Thank you.